Okay, today we're going to be looking at associated ratios and the value of a ratio. Basically, we're going to be looking at using fractions and ratios and the comparison and the difference between the two. So let's look at example number 1. Which of the following correctly models the number of red gumballs is 5/3 the number of white gumballs? And then we have 4 different options. For A, we have an option there's 3 red squares and 5 white squares. For B, we have 5 red and 3 white, 3 red and 2 white, and 5 red and 8 white. So now we got to figure out which one represents 5/3, or 5/3. The number of red gumballs is 5/3 number of white gumballs. Well, look, if we think about the statement, the number of red gumballs is 5/3 the number of white gumballs. Which one do we have more of? Do we have more red gumballs or do we have more white gumballs? Well, if red has 5/3 the number of white gumballs, 5/3 is an improper fraction, meaning that it's bigger than 1. So that means there are more red gumballs than white gumballs. So we know that there has to be more red. So that means that the answer cannot be A and the answer cannot be D. So then we're left with C and B. Well, for B, we have 5 red and 3 white, and for C, we have 3 red and 2 white. Well, let's see, we have 5/3 the number of white gumballs. Well, if we counted the number of white gumballs as a whole, as the whole number of gumballs, then that would be 1. And the 5/3 would mean we would have that, then we split into 3 pieces for the white. So you can see the white has 1, 2, 3 pieces. Well, the red then would have 5/3, or 1, 2, 3, 4, 5 of the thirds, and the thirds are the size of the boxes in the white. So therefore, B is the correct answer. Time to look at example 2. The duration of 2 films are modeled below. Film A and film B. You can see film A has 5 boxes, film B has 7 boxes. So it first asks us, well, what's the ratio of film A to the length of film B? Remember, for a ratio, we're just going to write the number or length of in the corresponding spot to its name. So we're going to write that a 5 in the first line because A comes first, and A has 5 boxes. Then we're going to write 7 on the second one because film B comes second, and so our ratio is 5:7. Well, B asks us the length of film A is blank of the length of film B with a fraction in there. Well, is film A shorter or longer? Well, we can see that film A is shorter, so that means film A is going to have to be a regular fraction. So it's below 1, meaning that it is smaller. So we're going to use the fraction 5/7. Okay. Now for C, the length of film B is blank fraction of the length of film A. Well, the B is longer than A, so the length is going to be 7/5. And we're just using these numbers we used it found in our ratio from our boxes in our tape diagram. So since B is longer, it has an improper fraction. Since A is shorter, it has a regular fraction because it is smaller or less than 1, whereas B is larger or bigger than 1. Okay, time to look at exercise 1. Sammy and Caden went fishing using live shrimp as bait. Sammy bought 8 more shrimp than Caden bought. When they combined their shrimp, they had 32 altogether. How many shrimp did each boy bring? Okay, so we have 32 shrimp altogether, and we got to figure out how much each boy brought. Well, Sammy had 8 more. So how are we going to figure out how much each of them had? Well, what I think is the way I would do it is I would take away those 8 that Sammy bought more. Let's take those away and basically give them to Sammy right away. So I'm going to do 32 minus 8. Okay, and that's going to get me 24. So now I know that there's 24 And those two are split evenly. Because I already took the 8 off that Sammy has more. So this 24 is going to be split evenly between the two boys. Well, 24 divided by 2 is 12. Okay? So 12 is how much Caden has. And then Sammy has the 12 plus the 8, which is 20. So Sammy, which we're going to use S for, has 20. And Caden, we'll use K for, has 12. So now we're going to add S. What is the ratio of the number of shrimp Sammy brought to the number that Caden brought? Well, Sammy has 20, Caden has 12, so let's put in the order that the problem asked for. So Sammy to Caden. So we're going to go 20 for Sammy to 12 for Caden. Express the number of shrimp Sammy bought as a fraction to the number of shrimp Caden bought. Okay, well, now remember, we're going with Sammy first. Sammy had more, so this is going to have to be an improper fraction. We're going to take his number and put it on top. So Sammy would be 20, had 20 twelfths the number of shrimp Caden had. D asks, what is the ratio of the number of shrimp Sammy brought to the total number of shrimp? Well, we remember that Sammy had 20, and then the total was 32. They had 32 together. So the ratio would be 20 to 32. Now, what fraction of the total shrimp did Sammy bring? Well, Sammy has less than the total number, so it's going to be a regular fraction. And we're going to have, so his number is going to go on top, so it's 20 out of 32. Okay, let's look at exercise 2. A food company that produces peanut butter decides to try out a new version of its peanut butter that's extra crunchy. Using twice the number of peanut chunks is normal. The company hosts a sampling of its new product at grocery stores and finds out that 5 out of every 9 customers prefers the new extra crunchy version. Let's make a list of ratios that might be relevant to this situation. The first one, the ratio of number of preferring extra crunchy to the total number surveyed. So we're going to start by those who like extra crunchy. Well, that would be the 5, because the 5 out of 9 preferred. So it would be 5, 2, 9, since it's out of every 9 customers. So 9 would be the total people they asked. Let's look at the second ratio. The ratio of the number of preferring regular crunchy to the total number surveyed. Well, we know the total is still 9, so we can fill that in for our second number. Then, the ones preferring the regular crunchy, well, 5 out of 9 prefer the regular crunchy. That leaves 4 who prefer the other kind, the original crunchy. So now we go to the third one, the ratio of people preferring the regular crunchy to the people preferring the new extra crunchy. We said the people who preferred the regular was 4, 2, the new, which was 5. And then the last one, the ratio of the number of people preferring extra crunchy to the new extra crunchy to people preferring regular crunchy. Well, it's the same thing, it's just flip-flop the order, since they flip-flop the order in the question. So this one would be 5 to 4. Okay, now let's look at these new problems which just appeared at the bottom. Let's use the value of each ratio to make the multiplicative comparisons for each of the ratios we described here. The number preferring new extra crunchy is blank of the total number surveyed. So we're comparing the new extra crunchy to the total number surveyed, which is up here on our top ratio. So we had 5 to 9. So to turn that into a multiplicative property, all you have to do is take this ratio, and we're going to turn to a fraction for the multiplicative property. So we're going to take 5 to 9, and we're just going to turn it into 5 ninths. So the number preferring new extra crunchy is 5 ninths of the total number surveyed, because it's 5 out of 9. The total number surveyed would be the whole, so now we have 9 pieces, and 5 of those 9 pieces are the people who like the extra crunchy. So look at the second one. The number of people preferring regular crunchy is blank the total number of surveyed. So again, we're just going to take our ratio from above. Here we have 4/9, so we're going to turn that into a fraction, and it's going to become 4/9. So the number of people preferring regular crunchy is 4/9 of the total number surveyed. Because again, the total number surveyed is going to be our whole, so we have 9 pieces in that whole, because there's 9 people, and 4 of those 9 preferred the regular crunchy. Let's look at the third one. The number preferring regular crunchy is blank of those preferring new extra crunchy. Well, again, we're going to look at our ratio above, and here we have 4/5. So we're going to turn 4 to 5 into 4/5. So it's going to become the number preferring regular crunchy is 4/5 of those preferring the new extra crunchy. So the people preferring the new extra crunchy is going to be the whole. So the whole has 5 pieces because there's 5 people. 4 of the 5 could also prefer the regular. And for our last one, we're going to again look at those preferring new extra crunchy is to those preferring regular crunchy. So again, we're just going to take our ratio and turn it into a fraction, so it's going to become 5/4. Okay, let's continue to look at this peanut butter situation. If the company is planning on producing 90,000 containers of crunchy peanut butter, how many of these containers should be the new extra crunchy variety, and how many of these containers should be the regular crunchy peanut butter? What would be helpful in solving this problem? Does our comparison statements above help us? So let's think back to our comparison statements. We said that 5/9 of the new extra crunchy, we'll put an EC for extra crunchy, those 5/9 of the total preferred the extra crunchy, whereas 4/9 of the total preferred the regular crunchy. We'll use RC for regular crunchy. So we can use these fractions to help us. We're going to take our 5/9, because as we said, it's 5/9 of the total. Well, our total is going to be 90,000. So we're going to do 5/9 of 90,000. So there we go, we're doing the 5/9 of 90,000. Well, we know that the word of in math means multiply. So we're going to do 5/9 times 90,000. Well, 5/9 times 90,000, we can think of 5/9 of 9 would be 5. Well, it's not 9, it's 90,000, so it's going to become 50,000. So that's going to be for the extra crunchy. It's going to be the same process for the regular crunchy. We know that 4/9 of the total being 90,000, is regular crunchy. So we can use 4/9 of 90,000. Remembering that of means multiply. So 4/9 of 90,000, well, 4/9 of 9 is 4. But since it's 90,000, it's going to become 40,000. And there we go. We have 40,000 regular crunchy. So how did our comparison statements from before help us? Well, it helped us figure out what the piece of the whole is each one. We figured out that 5/9 of the whole is extra crunchy, and 4/9 of the whole is regular crunchy. So we could just multiply those fractions times our total. For these next two, I'd like you to try them on your own after you hit pause, and then once you got them, hit resume, and then you can see the answers. Okay, let's check your answers. So for D, they made 2,000 of the regular crunchy. So we got to work backwards to figure out how much total did they make. So we can figure out how much extra crunchy they made. So instead of multiplying by a fraction of 4/9, since we're working backwards, we're going to divide by a fraction of 4/9. 2,000 divided by 4/9 got us 4,500. Well, if we have 4,500 total, we can then take our 4,500 and multiply it by our 5/9 to get 2,500 extra crunchy peanut butters. For E, we're going to do the same thing. This time we have 10,000 extra crunchy. So we're going to do 10,000 divided by 5/9 to get our 18,000 total packages. And then multiply that by the 4/9 to see how many regular crunchy we have. So 4/9 times 18,000 was 8,000 regular crunchy. Okay, try your luck with this last one before, and then once you got that, hit play again and check your answer. Okay, for our last problem, they had 3,000 containers of new extra crunchy. So we're going to take our 3,000 and divide it by our extra crunchy fraction of 5/9 to get 5,400. And then we'll take our 5,400, which is our total number of peanut butter they make, and multiply it by the 4/9 to get our 2,400 regular crunchy.